industry, the agricultural industry. And what am I doing in a climate session? Well, if you look, right, ag employs 1 billion people, generates $10 trillion worth of food annually, emits 1/3 of the world's greenhouse gases, and it's a primary driver of deforestation, and uses as much as 70% of fresh water. And we can change that. There's some simple traits that have a major impact on these climate limitations that I'll show you. So the company itself, we've been around for a while. We built a underlying genomic and computational biology platform, and now we've applied that platform to improving certain crops, mainly ones that are vegetatively propagated. We have a lot of experience. I think I count for 50 years of that 150. And we also focus on certain types of crops that are vegetatively propagated. These are crops that have been around for decades, and things like berries, fruits, nuts, bananas, avocados, grapes, citrus, etc. Many of these are vegetatively propagated, and the industry relies on certain varieties. I'll give you an example of nuts. The industry relies on a variety called nonpareil. It's been around for 100 years, and it has some problems that we've been able to solve with simple editing. Making a few changes, just base pair changes, to the nonpareil genome has generated a solution which saves 30% of land use. It reduces water usage by over 30% and increases products for the grower by a substantial amount. So there are other crops here I won't go into, but we don't do just almonds. We do many different crops. I want to use almonds as an example, and what we do is precision gene editing. Now, precision gene editing is a non-GMO technology. It's a simple path to deregulation. I'll show you a product that we just deregulated. It took us 4 to 6 weeks to go through the deregulation process to be able to release that without any labeling as a non-GMO product to the industry, which is now currently being sold. You have GMOs. There's a huge expense involved in GMOs and the regulatory hurdles that you have to overcome. With conventional breeding, this can take decades, especially in tree crops. Nonpareil, the variety I'll show you that we've edited, has been around for 100 years. And if you were to cross nonpareil, you would lose it forever. It's never going to come back. And the industry depends on this particular variety, especially California. So this editing technology has unlimited opportunities. And it's a way that we can address not only some of the agricultural problems, but also consumer issues as well. And keep in mind, this is a non-GMO technology, so it's very easy to not only deregulate, but there's consumer acceptance with the products that have been released so far. I'm going to give you one example, and that is, again, nonpareil, which is the #1 variety grown in California. And traditionally, this variety is the dominant variety for the industry. And it's also self-incompatible. A lot of fruits and nuts are self-incompatible. You need to grow 2 varieties to get a product. You need the pollinator, and then you need the plant, which is going to produce the nut. That takes up, in almonds, 30% of the growth of the area being used for almond production. So what we simply did was edit self-compatibility by just changing one gene in the genome of nonpareil. It's still nonpareil, it's identical to nonpareil, but now it's self-compatible. And that one trait alone is worth quite a bit of money. That trait accounts for, the nonpareil itself accounts for about 8 million trees replaced every year, with a royalty of $5 a tree. So you're looking at a $30 to $40 million royalty stream. We expect to capture 50% of that market in the next few years. The second variety that's grown, which is a late flowering variety, is Butte. We've already edited that for self-compatibility. That'll capture the late harvesting market as well. So this is one example of almonds. Apples are self-incompatible. The reason why if you planted an apple tree in your backyard that you don't get apples is because you need a second variety. And we'll have that available next year as well.
Thank you.
Thank you.
Questions? Thank you for the presentation. Could you talk a little bit about how you would distinguish the non-GMO element of this from the precision genetic editing piece? I personally understand the difference, but I think from a consumer perspective, it might require a little further explanation.
Yeah, that's a good question. So at Verinomics, we developed a technology called DNA-free editing. So we introduce the editing machinery into the cell. It creates the change in the endogenous gene without adding any DNA whatsoever to the genome. So that transgene-free editing process is key for editing vegetatively propagated crops so that they're non-GMO.
And how durable are those changes? Are they passed on?
They're permanent. They'll be around for the next 100 years.
Thank you.
So thank you for the presentation. It's obviously really exciting, huge opportunity. I, as a customer, look forward to consuming some of these products. I guess one of the things that you mentioned with regard to the self-pollinated trees at the end, it made me wonder about just kind of unintended consequences with perhaps the encouragement of the use of broad-spectrum pesticides in crops, and I guess just other unintended consequences with regard to manipulating crops over and above just that concern. Could you speak to those more generally?
Yeah, again, this has been around for over 100 years, and it's an extremely valuable variety. There's literally, we're making a change to just one gene, just a few base pairs to one gene to introduce self-compatibility. And so it had the genome of nonpareil that we've edited is identical to the variety that's currently being sold. The only difference is you don't need to plant 30% of that orchard with a pollinator in order to get nuts. This plant will self-pollinate and create nuts without that pollinator. So that's where the big savings and the big impact on water usage and other, I don't see chemicals as being increased, if anything, decreased, because the pollinator itself